So Professor Kleine, I'm back again, round 2 of stoichiometry. So here's the mole map. This diagram should help you see kind of how you solve stoichiometry problems. Most of them are just exactly like this. In a stoichiometry problem, you're starting out with some given amount of something. Let's call it substance A. You can start out in grams or liters of this typically. You convert usually that to moles of A. Now you do that using the periodic table, the molar masses of the elements. And then you have to convert from moles of A to moles of B. B is the thing you're trying to get to or what you're looking for. Now this is the mole ratio that I talked about in the last set of movies. Mole ratio. And then from moles of B you convert to grams of B or liters of B. So maybe you can make a diagram of this on your notebook paper. But this step here between moles of A and moles of B, you'll see that's in every problem. And you might not have to convert from grams to moles or liters to moles. We weren't in the last set of movies, but in this case, you always have to convert from moles to moles, as you're going to see. Let's look at a problem that's a little more complicated. In this problem, we have to do this problem in 2 steps. So here's a reaction between, this would be tetraphosphorus, decaoxide, and water makes, this is phosphoric acid. And the problem reads, given 35 grams of tetraphosphorus decaoxide, how many moles of phosphoric acid can be made? And you have to specify that you're not going to run out of water. You have plenty of water. You have enough water. Okay, so now to solve this, first of all, you always have to make sure you're working with a balanced chemical equation, which in this case I am not. So I'm going to first of all balance it. I'll put the balancing numbers in red. So I notice I have 4 phosphoruses and 1 here. So I'll start out putting a 4 there. I have 2 hydrogens and 4 times 3, or 12 hydrogens. So I'll put a 6 here. And then 4 times 4 is 16 oxygens. Turns out I have 10 plus 6. I have 16 oxygens. So just for the sake of the mole ratio, I'll put a 1 in front. Okay, now that I've got my balanced chemical equation, let me go ahead and start setting up the problem. So now this thing I was showing you in the mole map that we call A, it turns out it's going to be this material, because as you can see, I'm given a certain amount of that. So this is what I'm going to call A. And then what I'm looking for, how many moles of this. This is what was B in that mole ratio map you just saw a moment ago. And I'm starting with grams of this material, so I do have to take into account that. And I'm ending with moles of the phosphoric acid, so let's go ahead and set this up. Now the first thing I do is I write down the number in the problem, 35 grams. And then I put down what it is, P4O10. Okay, so there's no other unit, I'll put it over 1. Now, like I showed you in that map, you have to go from grams to moles of this material. Now, how do you do that, go from grams to moles of the material? Well, if you look on the periodic table, you'll notice that phosphorus has a mass of, I believe it's 31, and oxygen has a mass of 16. So if you add up the mass of all these atoms together, you get 284. That's 32 times 4 plus 16 times 10, for a total of 284. And that translates into a conversion factor between grams and moles of 284 grams of P4O10 is equal to 1 mole. Okay, now this factor here is the factor you need to convert from grams to moles, or I can flip it over like this, which is what I'm going to have to do in this case. I'm going to cancel grams, so 284 will be in the bottom. Okay, so let me put this up so you can see. Always make sure you have this information handy whenever you have a grams to mole problem like this. Okay, so now that I know that it's 284 grams of P4O10 is equal to 1 mole of P4O10, that means I can cancel the units and substance there. So basically now I have the same kind of problem as the last movie you saw, where it's going to be a mole to mole ratio, since I'm ending up in moles of this. Alright, so now I'm going to go from moles of A to moles of B. Without even thinking, I know that this moles and this unit has to go into the bottom here. And I'm looking for moles of this, so I'll go ahead and put that in there. Moles of this go here. Alright, so now the famous mole ratio step. I'm looking for moles of P4O10, which is 1 in this case, and moles of H3PO4, which is 4. So now I have the right units I'm looking for in the answer. The answer to this is going to be, the math is a little more complicated, 35 divided by 284, hit equal, times 4, hit equal, and that's your answer. So doing the math, you get 0.49 moles of H3PO4. So technically this is what we would call a mass to moles problem. A mass to moles problem is, as you can see, a two-step problem. Let's try another problem. This is another mass to moles problem. And so just like the other one, we're starting out with the chemical equation. Have to double check to make sure all of the formulas are correct. If there's ions and so forth, that's all right, it's perfect. And then we obviously have to balance the chemical equation or we can't solve it. So let's see. I noticed that I have 1 oxygen on this side and 1 oxygen on that side. I have 3 hydrogens on this side and 2 hydrogens on this side. Let's see. So what I'm going to do is put a 2 here to give me 2 oxygens and 4 hydrogens. And then I'll put a 2 here. That gives me 2 oxygens and 4 hydrogens. Since I have 2 sodiums, I need to put a 2 here. Okay, so reminding you, this means that there's 2 moles of sodium will react with 2 moles of water to make 2 moles of sodium hydroxide and 1 mole of water. Now solving the problem, I always start out with the given number here. Unit, I'm looking at sodium, so I'm starting with sodium, sodium in grams, and I have 21 grams. So starting the problem, I have 21 grams of sodium. Now the first step here is to convert from grams of sodium to moles of sodium. You always have to convert to moles because you need the mole ratio. So grams of sodium is pretty much useless to us. I don't care how much it weighs. I really want to know how many atoms are in there. And so moles converts it basically into the number of particles and atoms that I have. So I know from the periodic table that 23.0 grams of sodium is equal to 1 mole of sodium. Again, that's the number right off the chart, the periodic table for sodium. So that's going to cancel grams of sodium. Now I know how many moles of sodium I have. Now I need to convert to moles of the thing I'm looking for, which you can see how many moles of hydrogen. So I'm really going to ignore sodium hydroxide in this problem. I'm even for sure going to ignore water in this problem, even though they're there. They're not a part of the problem, so I'm not worried about those. But I am worried about the 1 mole of hydrogen. The mole ratio would say that 2 moles of sodium react to make 1 mole of hydrogen gas. And so since the unit here is how many moles of hydrogen gas could be made, I'm good to go on that. The math was pretty simple. It was 21 divided by 23, and that divided by 2 comes out to 0.91 moles of hydrogen gas. So here's another example of a stoichiometry problem. This is a mass 2 moles problem, like that. And so you see I start with mass and end up with moles.